Video is meant to chat through pages 6 and 7 of lesson 7. So here we are combining the variables. The relationships from the three experiments can be combined into a single expression to calculate heat energy. So here we have an equation that says Q, which is heat energy, is equal to mass times specific heat times change in temperature. So as we look at these individual variables, Q is the heat energy always measured in joules, M is mass in grams, C is specific heat, which we're going to chat about in a second, and then delta T is change in temperature, which is something that we've used before. So specific heat is an intensive physical property that has a different characteristic value for each substance. So there are different types of physical properties. Intensive physical properties are those that are the same for any substance, no matter how much of that substance that we have. Okay, so specific heat just happens to be one of those physical properties that is always intensive. So if, for example, the specific heat of water is 4.18 joules per grams degrees Celsius. So this would mean that it would take 4.18 joules of energy to raise the temperature of 1 gram of water by 1 degrees Celsius. If you need a little bit more explanation on this topic, we have two different videos here. One is just a quick definition. The next is a couple different examples comparing different substances. So this video compares sand to the water, kind of at the beach. It also compares, as you can see here, water and oil. So if you need a little bit more help, you can watch these videos. If you're not seeing them right here, the videos will be linked in the chemistry calendar. Okay, so this is the equation though that we're really kind of wanting to focus on. So as we move to page 7, so we need this equation, and here is the data that we're given. So we see that we are heating mercury and water. Hg is mercury, H2O is water. We have 100 grams of each substance. We have 1,000 energies, or 1,000 joules of energy, and then 2,000 joules of energy added to each substance, and we see what the temperature change was. Okay, so the first couple questions are just asking you to break down what this data is. So what are the two substances being heated? Compare the two trials. They use the same amount of energy, but involving different substances. So we're comparing the 1,000 joules to 1,000 joules, 2,000 to 2,000. Like, what's going on here? What can we say about how much mercury increased versus how much water increased? Okay, and then we're asked to start to do some math. So this question 7.3 is where we start to do a little bit of math. So I'm actually gonna shrink this screen a little bit. Oh, all the tabs. Okay, so shrinking that screen and then just moving my .cam stuff over here. Whoops, okay. So the first question is, based on data in this activity, the specific heat of water is determined to be 4.8 joules per gram degrees Celsius. Use data provided above to solve for the specific heat of mercury. Okay, so if we're going to try to solve for the specific heat of mercury, the first thing that I want to do is actually solve for specific heat using this formula. Okay, so C is specific heat. So if this is my formula, I can divide each side by mass and by delta T, and I end up getting C is equal to Q Q is the energy divided by mass and change in temperature. So now I just need to figure out some values to plug in here. Let me just draw that Q a little bit more obvious. Okay, so if I come back up here, my Q, and I'm just gonna go off of this first row here, okay? So my Q is going to be the 1,000, and that's divided by my mass, which is right here, 100 grams. And then my delta T, which is 71. Okay. When I solve that out, I should get 0.14 joules per gram degrees Celsius. All right, so the next question, so that was 7.3. Okay, so 7.4 is asking for a comparison. Okay, so when adding the same amount of energy to two similar massed samples, the substance with the larger specific heat will have a blank temperature change. Okay, so if we are looking at, so this is C for Hg, C for H2O was the 4.18 joules per gram degrees Celsius. Okay, so the thing that you want to look at is, so this is obviously larger. So the substance with a larger specific heat, did water have a larger or smaller temperature change? Okay. And you should realize that the substance with larger C takes more energy to heat. Okay, so if the substance with the larger C takes more energy to heat, then that means that the substance with the larger C is going to end up having a lower temperature. Okay, so moving on to 7.5. Just shift things a little bit here, sorry.